Hello there, Math 126 fans. Somebody on the discussion board is asking about this homework question. I'm going to go through it here in just a second. This is actually when I added this term because I just think it's interesting. I removed some other things, but briefly it's saying the following. Assume you know the initial velocity, and I've got a little visual here at the bottom so you can see this real quick just so I can state the question. Hang with me, we're going to do the problem in just a second. But assume I have this little visual. Assume it has some initial speed. Let's say it's fixed at 100. But you're allowed to change the angle. You've probably thought about these things before. You could ask, how can I make it go furthest? What's the angle? If you make the angle too small, it doesn't go very far. If you make the angle too big, it does this. So what's the furthest you can get? Well, I think a lot of people already know that if that's all we're dealing with is air resistance, it's at 45 degrees. That's the furthest you're going to get. This problem just takes you through that in a vector way. Okay, it's one of these problems that steps you through it. So sometimes students get confused about what to enter. So I want to talk about that piece and we'll go through it and it'll be hopefully interesting. All right. And of course, ask me on the discussion board if you have follow-up questions. So what they do is they take you through this. Apologize, I'm going to move a few things around. I know I just lost half my screen. Just bear with me a moment as I fix that up. And then we'll do this. I know what happened. Quick fix. Okay, so it says we're going to show what angle you want to use. We're going to have alpha be the angle. So the fact that they're assuming that the only force is gravity, and this is not a course about physics. They give you all this in the problem. Part of the confusion is they use i's, j's, and k's. So I'm going to write it as a vector here in a second because I think this is easier to think about. And mass times acceleration is force. And so you get the following. So you're going to get the acceleration is 0, negative g. And this is an extension of what you did in Math 125. In Math 125, you were just talking about the y component. Now we're going to talk about both. Okay, so what the problem wants you to do is to say, okay, now you know the acceleration. It's this thing. What happens when you integrate that thing? Well, you get the velocity is a constant here, and you get one. So you're just going to integrate both of these pieces. So you're going to get a constant, and you're going to get minus gt plus a constant. But rather than write it that way, they want you to split apart the stuff that actually came from the acceleration, which you could think of as this, and the stuff that came from the constants. So this is what they're calling C, and it's already written here. And let me get a little, adjust my screen slightly. I know you can't see something. Let's do a little adjusting. And let's do a few things here. Make this a little bigger. Apologies. Here we go. So they're calling that C, which means in this place, you're going to type in 0, negative gt. And you can put the t inside or outside. That's what I would type. I suspect in their solutions, they're going to write negative gt times j. But j is just a fancy way to write 0, 1. So that's still the same thing. So this or this. So that's what I'm going to type in. In a moment, I'll go look. Then they say, how would you get the next piece? But first we need an initial velocity. So what's the initial velocity? Well, it's going to depend on this angle. They're telling you the length of the velocity vector, and they're telling you the angle, and you're trying to figure out what these two components are. And so you're going to say that, well, the x component, or the change in x, so cosine of alpha, is the change in x over v0. So the change in x is v0 times cosine. So this initial x component of velocity is v0 cosine of alpha. And this one right here is going to be, by the same reasoning, v0 sine of alpha. Sorry if you hear my kids yelling in the background. Okay, so that's having you step through how you would actually find the constants. Okay, Then how would you do the next thing? You'd integrate again. Now in practice, these would all be constant. So if you think about what happens when you integrate again, you're going to get the following. R of t, you're going to get 1/2, and you can even just leave this in this vector form. This is what I do when I'm programming this in Desmos. And then I write plus, I take whatever these constants are, C1, C2, t, plus the location, D1, D2. So that's the general setup, and they were just talking you through it, making you think about the vectors. Okay, and if we say the initial position is here, then these are going to be 0, 0. Okay, so that's all the problem is saying here. It's taking you through the steps to get to this, which is exactly what this says. There's the 1/2 negative gt, which only affects the y. There's the initial x component of velocity. There's the initial y component. Okay, so if we are going to fill in the rest of the stuff, here's what we have. So we get this, it talks us through this, integrating again, we get what? So what you do in these problems when you're trying to fill it in, it's trying to help you, but you do it on your own and then you come up and check. And so you say, okay, what's the first thing we got? Well, we got 0, negative 1/2 g t squared. And what's the second thing we got? Well, this is already v sub 0. So this is what they're calling this vector. So I realize now I need to look at something, make sure. Yeah, they're calling that c. So this is just a t. So they're calling this v sub 0. Apologies. I don't know why they're writing it as a vector. I see. So there's a distinction between v sub 0 and the length of it. So I do understand the confusion there. Okay, so, and then it says here's the initial position, write down all the pieces. So let's fill that in. Since this is 0 is what they're saying, you're just going to write in the exact same thing. So 0, negative 1/2. But the goal is just to think about it a little bit. These are good things to ask about, like in the quiz section time. And then it says, if we call this the initial speed, what are these things? And it's having you think about some of the things you would have done if you'd have worked it out on your own as you write this out. Okay, then finally it says, if we're trying to find out the furthest it could go, we want to know when this is 0. That's when it's going to hit the ground again. When is it going to hit the ground again? We can solve for t by factoring. So the hardest part here is that you don't know what this is. You're treating it like a number. But if you have 0 equals, you factor out this t, you get this. And you get that either t has to be 0 or this has to be 0, which leads to t being this. That's where that's coming from. So then they say, what's the corresponding x? If that's your t, it's plugging you in. So I don't love these sorts of questions, but it's a chance for you to think through. It's kind of like a practice reading a book, reading a math book. So it's just saying, okay, what's going in there? So we don't have a lot of these questions, but a few. And then it says, what if you simplify this? Well, you're going to have this times this, and what's left? You're going to have 2 cosine of theta, sine of theta. And then they say, hey, by the way, that's that identity there. And this would mean, well, 1 is sine equal to 1. That's when 2 alpha is. So you have to think about when is sine equal to 1 on the unit circle, when it's pi over 2. And so then you get alpha is pi over 4. So those it's a different sort of question, but that's that 45 degrees. So those are the things you are going to enter when you go to do the homework. So that was sort of interesting. If I was typing this into Webassign, I would just use the angle brackets and just type it in like this. But something like this, I would do it on your own next to it, and then think about what goes in the spots. All right, I hope that helps. Let me know if you have follow-up questions.